Today we are going to see some more examples by using concept of UMVUE. So our example is T1 is UMVUE with variance sigma square, and it is a UMVUE, it is unbiased estimator for theta. Let T2 be another unbiased estimator for theta. Suppose the efficiency is given by variance of T1 divided by variance of T2. This is the efficiency of T2 with respect to T1. Then we have to show that correlation between T1 and T2 is the square root of E. So we have to prove the correlation between T1 and T2 is the square root of T. To prove that, we will consider example result. If T1 and T2 be two unbiased estimators of theta, then with the variance sigma 1 square and sigma 2 square respectively, then the best linear combination having least variance, that is minimum variance, is T is equal to L1 T1 plus L2 T2, where L1 is given by sigma 2 square minus rho sigma 1 sigma 2 divided by sigma 1 square plus sigma 2 square minus 2 rho sigma 1 sigma 2, and L2 is given by sigma 1 square minus rho sigma 1 sigma 2 divided by sigma 1 square plus sigma 2 square minus 2 times rho sigma 1 sigma 2. This is a best linear combination having least variance. So what we have now? So we have T is UMVUE with variance sigma square. We have given efficiency, which is given by variance of T1 divided by variance of T2. So variance of T2 implies variance of T2 is equal to variance of T1 divided by E, that is sigma square divided by E. So we have sigma 1 square, that is sigma here, and sigma 2 square is sigma square by E. Now we will put these values in L1 and L2. What we have? L1 is equal to sigma 2 square. Sigma 2 square is a sigma square divided by E minus rho sigma 1, that is sigma square square root sigma, and sigma 2 is a sigma upon root E divided by sigma square by E plus sigma square minus 2 rho sigma square sigma minus 2 rho sigma into sigma upon root E. Here sigma 1 sigma 2 is there. So with this, now we will put the values in L2. So here it is sigma square minus rho sigma into sigma upon root E divided by sigma square plus sigma upon root E, sigma square upon E minus 2 rho sigma into sigma upon root E. So we have put the value in L1 and L2. Now we will simplify this L1 and L2. So take outside sigma square by E common. So remaining is 1 minus rho into root E, because we have take outside common as sigma square divided by E. So this what we have. Then again take sigma square upon E from this bracket common. So 1 plus E minus 2 rho into root E. Now what we have L2? L2 is take sigma square upon E common. So sigma square upon E common. So E minus rho into root E, and take sigma square E common. So 1 plus E minus 2 rho into root E. So finally what we have? So sigma square got cancelled. So L1 is equal to 1 minus E into 1 minus rho into root E divided by 1 plus E minus 2 rho E, and L2 is given by E minus rho root E divided by 1 plus E minus 2 rho root E. So now we will put this as a D. So L1 is equal to 1 minus rho root E divided by D, and this L2 is E minus rho root E divided by D. So this is the values of L1 and L2. So we have got the L1 and L2 in terms of rho and E. Now we will find the variance of T. So variance of T is where T is L1 L2 plus L2 L1 T1 plus L2 T2. Where what is T? L1 T1 plus L2 T2. So this is equal to L1 square variance of T1 plus L2 square variance of T2 plus 2 times covariance between T1 and T2. So now we will take. So variance of T is equal to variance of L1 T1 plus L2 T2, and that is L1 square plus variance of T1 plus L2 square into variance of T2 plus 2 times covariance of T1 T2. So now we will put value of L1 and L2. So L1 square is 1 minus rho into root E bracket square divided by D square plus into variance of T1 is sigma square plus L2 square E minus rho root E bracket square divided by D square into variance of T2 is sigma square upon E plus 2 times L1 L2 that is multiplied here L1 L2. So L1 L2 is 1 minus rho root E divided by D into E minus rho root E into sigma upon root E. So now take sigma square upon D square outside the bracket. So here remains 1 minus rho root E bracket square. So here sigma square upon D square get outside the bracket. Here take minus square root of E as a common. So it's square into square root of E minus rho bracket square divided by E plus 2 times. So 1 minus rho root E into take root E common into root E minus rho divided by root E. So this bracket gets completed. Now sigma square upon D square. So this bracket we will expand 1 minus 2 rho root E plus rho square E. This square root of E square divided by E gets cancelled. So this bracket is E minus 2 rho root E plus rho square plus 2 times. Here it is rho. Rho is a correlation coefficient between T1 and T2. So we have to write rho here. So 2 times rho into multiply those brackets and root E get cancelled. So root E minus rho minus rho into E plus rho square into root E. So sigma square upon D square 1 minus this minus 2 row root e, 2 minus 2 row root is minus 4 row root e plus e minus plus rho square into e, these form terms here, plus rho square plus multiplied this 2 row root e minus 2 root 2 into row cube row square 2 into row square minus 2 row square into e plus 2 row cube into root e. So we have multiplied this bracket by this here. We have got root e minus rho minus rho into e plus rho square into root e multiplied by 2 rho. So now we will simplify it as, so variance of t is sigma square upon d square. So 1 remains minus 4 root e into 2 row root e, so it get minus 2 into row root e plus e, this row square e minus 2 row square e is minus row square e plus row square minus 2 row square minus row square plus 2 row cube into root e. So now sigma square upon d square. So here we can take these terms as and take outside common row square. So 1 minus 2 row root e plus e minus row square, take outside, so here e plus 1 minus 2 row root e. So sigma square upon d square 1 minus 2 row root e plus e into 1 minus row square. So variance of t we have now. This is variance of t. So variance of t divided by sigma square is equal to 1 minus 2 row root e plus e into 1 minus row square divided by d. So this ratio is less than or equal to 1. So this ratio is less than or equal to 1. What it means? Variance of t is less than or equal to sigma square, which is variance of t1. So here we what we have, variance of t is less than or equal to sigma square, which is variance of t1. But t1 is UMVUE. So T1 is UMVUE, so its variance will be minimum, and we have result that the linear combination of L1 T1 plus L2 T2 has also least variance, that is it is also UMVUE. So variance of T is equal to variance of T1, which is equal to sigma square. So this is less than or equal to sigma square, but this is also T1 is UMVUE, so its variance should be matched with variance of T. So this is equal to this, and then we will put the value. So 1 minus 2 row root e plus e into 1 minus row square divided by d square, and 2 is equal to 1, is equal to 1. So now we will is equal to 1. So now what is the value of d? We will put it 1 minus 2 row root e plus e into 1 minus row square divided by, so what is the value of d? 1 plus e minus tau rho root E, that is value of D. So 1 plus E minus 2 rho root E bracket square is equal to 1. So what we have? So 1 minus rho square divided by 1 bracket get cancelled. So 1 plus E minus 2 rho root E is equal to 1. So we will take it on another side, multiply this. So it implies 1 minus rho square is equal to 1 plus E minus 2 rho root E. So 1 get cancelled. So this is equivalent to, this is equal to E minus 2 rho root E plus rho square is equal to 0. 1 get cancelled. And we have taken this on right hand side. So this is equal to 0. So this is E minus, so this is equal to rho minus root E bracket square is equal to 0. So what we have? So rho is equal to root E. So this is final expression. So correlation between T1 and T2 is root E. That is our example. So we have proved that if T1 is UMVUE and T2 is any other unbiased estimators, then correlation between T1 and T2 is root E. Now we will use this result and solve another example. So our another example is if T is UMVUE, if T is UMVUE and T1 is any unbiased estimator, T1 is any unbiased estimator, then prove that variance of T1 minus T is equal to variance of T into 1 minus E divided by E. To prove this, we have used this result what we have earlier. Correlation between T1 and T is root E. We have this result. So correlation what we have? So variance of T1 minus T is equal to variance of T1 plus variance of T minus 2 times covariance of T1 into T. So now we have given, so we have given efficiency is equal to variance of T divided by variance of T1. So variance of T1 is equal to variance of T divided by E. So we will put it as variance of T upon E. So variance of T1 minus T is equal to variance of T upon E plus variance of T minus 2 times correlation is root E into their variances into square root of variance of T into variance of T1 is variance of T upon E. Variance of T1 is T upon E. Now we will put the values. So variance of T upon E plus variance of T minus 2 into E into this is variance of T upon root E. So root E get cancelled. So variance of T divided by E plus variance of T minus 2 times variance of T. So now what we have? So variance of T upon E minus variance of T. Now we will take variance of T as a common. So 1 upon E minus 1. So variance of T into 1 minus E divided by E, that is variance of T1 minus T. So we have proved this result. So thank you. Now we will see another example for UMVUE. Our next example is
we will stop here.